everybody. In this video, we're going to talk about the order of operations and the distributive property. So let's talk about the order of operations first. So the reason why the order of operations is important is because when you have multiple operations, and operations are things like addition, subtraction, multiplication, division, basically things that you do with numbers or calculations that you make with numbers. When you have multiple of them in the same math expression, it's important to know which ones you need to do first because you'll get different results depending on which operations you do first. So one of the most common mnemonics for remembering the order of operations is PEMDAS, or please excuse my dear Aunt Sally. And what that means is that you do parentheses first, then you do exponents, then you do multiplication and division from left to right, whichever one comes first. Then you do addition and subtraction from left to right, whichever one comes first. And that's the order that you do the operations in. I've also seen the mnemonic GEMS, which communicates a similar thing. G stands for groupings, because sometimes the groupings are not just parentheses, sometimes they're brackets or braces or other things like that. Then you do exponents, then you multiply and divide from left to right, and add and subtract from left to right. So both of these mnemonics are ways that many people remember how to do the order of operations. But PEMDAS is definitely the most common, and I actually don't like it very much because there's a very common problem that comes up when students are solving problems with PEMDAS. So if you had an expression like this, the correct way to use PEMDAS would be to first look and see if you have any parentheses, which we don't. We also don't have any exponents. And then you would want to do multiplication and division from left to right. So in this case, that means you would do 64 divided by 8, which is 8, multiply by 4, which is 32. So you would rewrite this as 100 minus 32 plus 6. Then you would do addition and subtraction from left to right, and you would say 100 minus 32 is 68, 68 plus 6 is 74, and so that would be the correct answer. Now, one of the most common mistakes that I often see my middle school and high school students make is they do PEMDAS in the order that the mnemonic tells them to do. They say no parentheses, no exponents, but I do have multiplication. So they'll think of this as 100 minus 64 divided by 8 times 4, which is 32. And then they'll add 6. So they simplified the multiplication. Then they'll simplify the division. And they'll say 64 divided by 32 is 2. So I have 100 minus 2 plus 6. Then PEMDAS says to do addition next. So I'll do 2 plus 6, which is 8. So I get 100 minus 8. Then PEMDAS says to do subtraction, so I'll subtract the 8 and I get 92. And as you can see, that is a very different answer than the correct answer, which is 74. And the mistake that they made was they didn't do multiplication and division from left to right, or addition and subtraction from left to right. But the mnemonic, PEMDAS, told them multiplication, then division, addition, and then subtraction. And that little stipulation that you have to do it from left to right can often be very confusing for students. So the way that I actually like to teach order of operations is by going back to how math is built. And I really like using this method because it also gives them a really strong foundation for solving equations later on in middle school. So the way that I teach order of operations is I talk about how the operations build on themselves. So when we first start learning math, the first operation we learn is addition. And then we learn that you can undo addition by subtracting. So addition and subtraction are inverse operations of each other because they undo each other. Then we learn that if you repeatedly add the same number together, we can think of that as being multiplication. So repeated addition creates multiplication. And the opposite, or the inverse of multiplication, is division because multiplication and division undo each other. Then repeated multiplication makes exponents because if you repeatedly multiply the same number together, you can think about that as being an exponent. And the thing that undoes an exponent is a root. And I think roots are introduced in 8th grade. So you probably won't have any of those with your students. But it can still be helpful to let them know that that information is coming later. And so when you talk about how math is built in these layers where repeated addition makes multiplication, repeated multiplication makes exponents, the order of operations basically says you just do the hardest thing first and you work your way down the pyramid. So you simplify exponents and roots, then you simplify multiplication and division, then you simplify addition and subtraction. And notationally, we just simplify them from left to right because that's the way that we write math sentences. And then parentheses trump all of them. So if they want you to calculate any of these operations out of order, then they'll put parentheses around it to give you the hint or the notification to say, hey, do the addition before you do the multiplication. And so parentheses are basically just what we use to show that we want to do something out of the typical order of operations. And again, one of the reasons I really like using this model to teach order of operations is because when you solve equations, you actually solve equations in the opposite order of operations. Like, for example, let's say you had something like 2x squared plus 1 equals 19. The way that you would solve this equation is you would undo the addition and subtraction first. So you'd subtract 1 from both sides, which gives you 2x squared equals 18. Then you would undo the multiplication by dividing, which gives you x squared equals 9. And then you would undo the exponent by taking the square root of both sides, which gives you x equals 3. And technically, x also equals negative 3, so there'd be two solutions there. But basically, when you're solving equations, you work backwards from the order of operations. And so having this structure in mind can be really helpful for students later on. And now the next thing we're going to talk about is the distributive property of multiplication over addition. So this equation that I have written here is an example of something you might see in an algebra class. And I'm going to explain how I explain the distributive property to my algebra students first, and then we'll talk about how it relates to elementary math. So the basic idea of the distributive property is that if you have things that are added together inside of parentheses, and that whole set of parentheses is multiplied by something, you can multiply each part or each term inside of the parentheses to get an equivalent expression. And the reason why this works, I like to draw pictures to show my algebra students this, is because if I have 3 x's and 4 y's, I can model that with 3 x's and 4 y's. And if I multiply that by 2, I'm making 2 copies of it. And then the reason why this is equivalent to 6 x's plus 8 y's is because if you take the x's out of the groups and just combine them together, you have 6 x's. And if you take the y's out, you have 8 y's. And this is the reason why the distributive property works. Now, in an elementary classroom, you're not going to be solving problems like this because usually you don't work with variables in elementary school. But you could use the distributive property to simplify a problem like, let's say, 3 times 24. Because 3 times 24 might be kind of hard to calculate in your head, but if you think about it as 3 times 20 plus 3 times 4, then suddenly it's a lot easier because 3 times 20 is 60, 3 times 4 is 12, and if you add those together, 60 plus 12 equals 72. And so 3 times 24 equals 72. And the reason why this is the distributive property is because you're thinking of 3 times 24 as 3 times 20 plus 4. And then that 3 times 20 that we got the 60 from is basically just distributing 3 times 20 and then 3 times 4 gives you the 12. And so that's a place where it would show up more in an elementary school classroom. And it may also show up in the ways that your students solve different problems. Like, for example, if you were to give your students this word problem where it says a bag of Snickers weighs 2/3 of a pound, and Millie has a half a bag of Snickers and Joey has a fourth a bag of Snickers, how many pounds of Snickers do they have together? Your students may solve them in very different ways. So I actually want you to pause this video and solve this problem in whatever way you think would make the most sense to you. And I encourage you to try to do it without equations. Just maybe like draw some pictures and try to think about it the way that a student would think about it if they haven't had a lot of experience writing out math expressions. So pause this video, try it for yourself, and then restart it, and I'll show you 2 different ways that your students might solve this. Okay, so let's say that you ask your students to solve this, and you look at one of your students' work, and this is what they drew. So just take a minute, maybe pause the video and look at how they calculated this and see if you can figure out what their reasoning is. And then I'll talk you through kind of the way that I would interpret this student work. Okay, so what I see here is, first of all, it looks like the student took this fact that Millie has a half a bag of Snickers and Joey has a fourth a bag of Snickers, and it looks like they drew these 2 pictures. So Millie has a half, Joey has a fourth, and then it looks like they combine them together to say that together they have 3/4, which we can kind of see here. So what I'm seeing is that the student calculated 1/2 plus 1/4 equals 3/4. So that's kind of the calculation that they were doing there. And then it looks like they took this 3/4 of a bag of Snickers and they drew it inside of a rectangle that represents a pound. That's kind of what I'm seeing there. And the way that they drew it, it looks like this line and this line are splitting the pound up into thirds, and that's how they represented that one bag is 2/3 of a pound. And then it looks like the part that Millie and Joe had were 3 of these little squares here, and they said that Millie and Joe have 3/6 of a pound because this line right here splits the entire pound up into sixths. And so it looks like what they did there was they multiplied this by 2/3 because they realized that each bag is only 2/3 of a pound. And so they multiplied that by 2/3. And that's how they got the answer of 3/6, because 2/3 times 3/4 equals 3/6. So that's what I'm seeing in this expression here. So the way that this student calculated this can be represented with this expression here, because they first added the 2 bags together to figure out how many, how much of a bag of Snickers they had together, and then they multiplied by 2/3 because each bag is only 2/3 of a pound, and so they needed to figure out how many pounds of Snickers they had together. So this is one way that a student might solve this problem. Here's another example of how a student might solve this. So again, I'll give you some time to pause this video and look through this student work and see if you can figure out what this student did. Okay, so when I look at this student work, this first piece right here, it looks like they drew a rectangle for 1 pound, and then they showed what 2/3 of a pound would look like with this black shading. So basically that black shading is a bag of Snickers. And then it says that Millie has a half of a bag of Snickers, and that's what they shaded in pink. And you can see they kind of color-coded that by saying that the pink part was Millie's candy. And then it looks like they used that information to find out that Millie has 2/6 of a pound. And then they did something similar with Joey's. So they took Joey's pound, they split it up into thirds to say that that's a bag of Snickers. And then Joey has a fourth of it, so it looks like they split that up into fourths. And Joey has 2 of those sections, and there's 12 sections in the entire pound. And so that's where they get this. And then it looks like they added the fractions together and they found common denominators. Notice in this case that you might want to go over, like if this was one of your students, you might say, oh, like I'm noticing that they don't understand the concept of least common multiples, because 72 is a common denominator that works, but it's not the easiest common denominator, because it would have been easier to get a denominator of 12. So that might kind of give you a clue as a teacher that you might want to review that a little bit more. But he did convert the 2/6 and the 2/12 into 70 seconds correctly. And the answer was 3670 seconds of a pound, which if you were to reduce this, this would equal 1/2 because you could divide the top and the bottom by 36. And so the way that I would help this student write their thinking in a mathematical sentence is it looks like he did 2/3 times 1/2 because that part is describing how many pounds of candy Millie has. And then he did 2/3 times 1/4 to get the amount that Joey has. And then he added those two together to figure out how many pounds of Snickers they had together. So if you had two students who solved these problems in these ways, you could use their work to help your students discover a relationship between these two equations or these two expressions. So the way that Josh, let's say that Josh was the student who solved it the first way, the way that he solved it was he did 1/2 of a bag plus 1/4 of a bag to get the total amount that Millie and Joe had, which was 3/4. And then he multiplied that by 2/3. So he did 2/3 times 3/4, which ultimately gives you 1/2 if you reduce this 3/6 fraction. So that solution is showing this, is like kind of a representation of this expression. Then let's say that Abby solved it the other way. Well, in this case, you're figuring out how many pounds 1/2 of a bag is, how many pounds, this should actually be a 4, not a 6, how many pounds 1/4 of a bag is, and then combining those two amounts together to get the total number of pounds that they have together. And you could use the fact that this expression and this expression give you the same result to show that those two things are equal. And so maybe you might want to put this on your equation board and you say that this method of solving the word problem was the same thing as this method. And if you wanted to help your students understand the distributive property in more depth, you could give them another problem like this one, where Julie is making a double batch of cookies and the recipe for one batch says to add 2/3 cups of brown sugar and 3/4 cups of white sugar. And then the question is how many cups of sugar will be in Julie's entire double batch? So I'm not going to go through this problem. This is actually one of the options that you guys have for your lesson dialogues this week to go through and think about how students might solve this. But it's very likely that your students would use a method that might result in an expression like this, and other students might use a method that results in an expression like this. And ultimately, they'll both come up with the same answer, and you could add this equation to your equation board. And once you've done a couple word problems like this, you can help your students start to realize the pattern that if you have something multiplied by a set of parentheses with things added together, you can multiply it by each of the things that are added, and the result will still be the same. And again, that should be a 4, not a 6. And same thing here. If you multiply the 2 by each of these fractions, the result will still be the same. So if you're interested in exploring this more, you can choose that option for your lesson dialogue. And if you have any questions, let me know.